This is Making Predictions, presented by Andrew, Jose, and Tristan. Here's our social contract. So we're going to start off with define the problem. So for the problem, in this project, we will collect data from our chosen topic, and we will create charts through code, and with these charts, we will make predictions. So here are the requirements. The requirements are here that we get this project done in reasonable time while still meeting all the information that we need. Here are the brainstorms. This is basically our keys to success. We're using these brainstorms to help get our ideas. And for our preliminary research, we researched some topics that have vast amount of data and ones that we were somewhat interested in. And so this kind of helped us pick our topic in a reasonable time. And so from what we chose, our three big ideas were meteor landings, car crashes, and bird population. And the one we ended up going with was car crashing based on experience, so age or years of driving of the victim. So for planning a solution, major parts of the solution are the big things that we want to get done. These are our information. So for us, it would be number of car crashes, ages of victims, and how your age affects your ability to drive. By deciding these major parts, it helps us get the information for the spreadsheets more effectively and just builds our time better. Feasibility, this is how possible it is for us to get these things done. The way we calculated or I came up with the feasibility for these is we looked at the requirements and what we needed to have on our slides for the presentation, and we kind of just went down the checklist of what we needed and made plans of how we would reach each milestone or part. After planning out, we realized we should be able to get all these done in a viable amount of time. So here are our milestones. These are kind of just things we want to get done or we want to see improve through these presentations. We have things like learning to build effective presentation, communicating properly with code without the help of AI, and learning to evaluate constructively and to learn to freestyle, because you won't always have a set requirements, set of rules. Next is design solution. So here are our diagrams. This is of our major parts, so you can see crashes, age, and ability to drive. These are how we would kind of form these major parts. So for meeting requirements, we kind of went down the requirements and just checked off the little check boxes to see if we do have all the requirements met or if we can get the requirements done later on in the presentation. For feasibility, again, to know if the goals we put on ourselves for this project were feasible or not, we planned the steps, we looked at the goals we wanted, the requirements we needed, and we kind of just said, okay, we should be able to get this done in the time we have. And to back up our feasibility, here's just showing how much data we do have to our access, which is one of the requirements. We were required to have enough data for this project, and as you can see, here we have collisions, we have age groups. Later on, you're going to see that we have a ton of resources from the data we collected. Here's our pseudocode. This is just kind of a breakdown of what we think the code is going to look like. As you can see, it says it's going to collect data, print crash data, print age data, create values, make ranges, create X and Y axis, and graph the data. Here's our Gantt chart. This is who did what on what specific days. As you can see, there is 5 major parts. First, we have the define problem, which includes the problem, goals, checklists, and choosing idea. Then we have planning/design, or just planning for this one, which is major parts, feasibility, and milestones. For design solutions, we have our diagrams, meeting requirements, our pseudocode, and Gantt chart. For creating tests, we have getting files, abstracting, and making charts. And then finally, for evaluate solutions, we're just taking and giving evaluations and presenting. We're just making our video. So finally next we have create and test. So here's our data collection. This is a form of pretty much all of our data. There's a little bit more from this. We just didn't get both screenshots. But we did not have to physically, or I guess we didn't have to hand make our CSV file, as we got our file from one of the links that PLTW already had. So we just downloaded that CSV file that had the information we needed. So here's our code. You can see what the code does. 1 through 3, we're just importing anything needed for the code. 6 through 7 specifies the location of the data. 10 through 11 prevents errors from checking for files before running, and you'll understand why we put that in later. 14 reads CSV file into data frame. 17 through 19 assumes data is from 2003, which it is, and estimates age using the equation 2023 minus car year plus 4. You'll understand why we did that later. Line 21 makes age ranges. 25 through 26 separates age into 2-year intervals and make bars visible. 27 through 29 adds Y and X axis labels. 23 adds grid lines, and 31 renders histogram. So explanations. For line 10 through 11, when we first ran the code, it would give us errors on our file. It wouldn't properly run the files, which made it not be able to abstract the information. So we added this as kind of like a safety measure, so that if, again, it doesn't run the code, it won't give us an error this time. It'll kind of say the code didn't run or whatever. And for the initial plan was to have the data of the age groups. We wouldn't have needed the calculations if we had the actual data of age groups that were the victims. Unfortunately, the CSV file that we used for that, for whatever reason, just could not work whatsoever. We couldn't abstract the data from that, so we ended up just having to use a calculation that we kind of not so much came up, but it was more of a calculated guess from like minimal level of research that we were able to do. So our ran code, once we ran the code, this is what it gave us. Obviously, this is very much wrong. The number of crashes is correct, although obviously you don't stop having crashes at the age of 40. So, although the number of crashes is correct, the ages are wrong. So here's the debug chart. You can kind of see the comments, what the code does, and corrections. I'm going to just go through the main points. For define the correct file path, we needed to make a correction. When we first made the code, was not able to abstract files, so we added the next piece of code, which was check if file exists before proceeding, which allowed code to ensure file is actually where it's needed. And for assuming dataset is from 2023 and estimates drivers, although it does what it's supposed to do, in a perfect world, this would be something else. This would be abstracting data from another CSV file with the age groups. For our milestones, this is kind of just us updating on what our milestones were. So from these milestones, we finish abstracting data, communicating probably with group, learning to work through a project without help of AI, yada, yada, yada. There is some that we either were not able to accomplish or that we would accomplish just later on in the project. And so for our hypothesis, we concluded that younger drivers were the most prone to these car crashes. Obviously, the chart isn't fully correct, but is still correct in the fact that younger drivers and less experienced drivers were more prone to get into accidents than more experienced ones. So evaluations. These are the evaluations we received from Quentin's group and Levi. And here are the evaluations we gave. And how we improved, we just kind of took the overall message of what the other groups were saying, and we just looked back, reorganized our slides, documented a little bit more, and just adjusted some stuff. And next is our recording.